Okay, today we are coming back to learn 3.6, Rationalizing the Denominator, which we've already done before, but now we're going to be talking about imaginary, binomials, and complex numbers. Excuse me. So we're going to be rationalizing each of the following. We're going to be showing all our work, and we're going to be putting our final answer in A plus BI format. Okay, so first things we're going to look at are imaginary monomials. So number one, we have -2 minus 3i divided by 5i. So keep in mind that we got to remember a couple of things. One, that I squared equals -1. Gotta remember that. And we also need to remember the basic concept of rationalizing. Remember that rationalizing the denominator refers to multiplying by itself or by the denominator on top and bottom to simplify the denominator. And in this case, it doesn't have a radical in the denominator, but it does have imaginary. And we don't like imaginary numbers in the bottom either. So we're going to multiply by the imaginary part. You don't need to multiply by the entire part. You only actually have to multiply by the imaginary part. And because if you multiply an I by an I, you get I squared. And so that's where we're going with this. So multiply by I to the numerator and denominator equals, now on top you're going to have to distribute. So -2 times I would be -2i. -3i times I be -3i squared, divided by 5i times I, which would be 5i squared. And then we have to show our substitution method, which would be -2i minus 3 times -1 divided by 5 times -1. Again, I squared equals -1. That's where that comes from. And then we got to simplify this. So then we get -2i, -3 times -1 is +3 divided by -5. Now, when we write this final answer, we're going to have to change the format a little bit. So as it is, there's nothing we can simplify, but we can change how it is written. So for first thing we got to do on top, remember that we want it to be A plus BI format always. So just looking at the numerator itself, we need to change that order. So it'd be 3 minus 2i divided by -5. So now the numerator is written as A plus BI format, but we actually want the entire thing to be written as A plus BI format. And so in order to do that, we're going to change our fraction. Rather than writing it as a whole fraction over -5, we're going to split it into two fractions. So 3 divided by -5 is -3/5, and -2 divided by -5 would be +2/5 I. And so when you do that, now you officially have it in A plus BI form. Okay. So again, although this was simplified as possible, we first needed to make the numerator A plus BI format, and then we made the entire answer A plus BI format, which will go obviously which will obviously go faster in the future. Let's try number 2. 4 plus 5i divided by -3i. Okay. Again, we're going to multiply by rationalizing with the imaginary unit. So we get 4i plus 5i squared divided by -3i squared. I'm going to put in our negatives, numbers. Okay. And then we're going to simplify. Now, when we simplify, oh, sorry, you can't even see that. When we simplify, you can rewrite it right away for the numerator to be rearranged. So I could rewrite it as -5 plus 4i, because I already know that it needs to do that. And then -3 times -1 is +3. So I need to see this, and then you can split it apart. So you can kind of skip this step because you're going to eventually realize that that's going to happen always because you're multiplying an I times an I. So you're going to insert or substitute a -1. So it's always going to simplify. So then we get -5/3 plus 4/3 I. That's our final answer. Okay. I'm going to write down number 3, and I'd like you to try it without looking at the final answer first to see if you understand that concept. Okay, so I'm going to pause the video. I want you to pause it as well. Okay, let's see how that went. Hopefully it did go well. So multiply by I, top and bottom, -2i plus 6i squared divided by 9i squared. Substitute in our -1, which must be shown, and then rewrite it. So we know 6 times -1, -6 can be brought to the front. 9 times -1, -9. And then we're going to change this into a plus bi format. But if you notice, we do have a fraction that gets simplified. -6 divided by -9. Well, it will turn positive, but 6/9 would simplify to 2/3, and -2 divided by -9 would become positive 2/9. So it is possible that the fractions will simplify. We just hadn't had one yet. Okay, so 2/3 plus 2/9 I would be your final and correct answer. So hopefully that one went well for you. Okay, and so that is our imaginary monomials. Okay, now let's look at our next example. Okay, our next option, our next type of problem is complex binomials. Okay, complex binomials. Or sorry, that's not what I meant to say. Sorry, that's the last one. It's not complex binomials next. It's let's try that again. That's the last one. Sorry, we have binomials with radicals first. I guess technically we could have done that next. But we're going to do binomials with radicals. Okay, so number 4. 3 square root of 2 divided by square root of 5 minus the square root of 2. Okay, now the first thing I'm going to say is remember, this cannot be simplified, okay? You cannot subtract 5 minus 2 and call it a day. That doesn't work, okay? They are two separate radicands, so therefore they cannot be combined. Refer back to when we did adding and subtracting, okay? So that's my first step and first conversation. Okay? So what we do need to do is that we have a binomial with radicals in the denominator. So therefore, we're going to rationalize by multiplying by the conjugate. We're going to multiply by the conjugate. Okay. Now, what is the conjugate? Okay. Well, it is the denominator binomial with the opposite middle sign to be multiplied to top and bottom. Okay. So when we multiplied and we had a single radical, we would just multiply by that radical. But now we have two radicals and it cannot be combined. So therefore we need to multiply by the conjugate. Now again, the conjugate is the denominator binomial with the opposite sign, opposite middle sign, to be multiplied on top and bottom. So what does that look like? That means we're going to be multiplying by the square root of 5 plus the square root of 2 on top and bottom. Okay. Again, the only change is that sign, that middle sign, right? That's the only difference. That makes it the conjugate. Now, what is that going to look like? Well, it does mean that you're going to be doing a lot more multiplying. Okay, so it means that we have 3 square root of 2 times square root of 5 plus square root of 2 divided by square root of 5 minus square root of 2 times square root of 5 plus square root of 2. Okay, we're going to have to multiply all that out. So I'm just going to skip over my work, over all my information. We're going to come down here. Obviously, this would not be a normal problem. And we're going to start multiplying. So remember, with multiplying, you can multiply the radicands as long as the root's the same. So 3 square root of 2 times square root of 5 would be 3 square root of 10. 3 square root of 2 times square root of 2 would be 3 times square root of 4. And divided by, now down here we have two binomials. That means we have to FOIL. So square root of 5 times square root of 5, square root of 25, square root of 5, square root of 2, positive square root of 10, minus square root of 10, minus square root of 4. Okay. At this point, I'm going to clarify that you cannot simplify on top and bottom until it is as simplified as it can be. Okay, don't go canceling out square root of 4, square root of 10. You have to simplify the numerator, simplify the denominator before you could even think about simplifying via vertical. So horizontal simplifying first, then you can simplify vertically. So don't go canceling anything out right now. But we can simplify right now within the numerator and the denominator. So looking at the numerator, we have square root of 4, which we know is 2. So really, this should be 3 times 2. And 3 times 2 is 6, so I'm going to write it as 6 plus 3 square root of 10. Okay, now in the denominator, square root of 5 is, square root of 25 is 5. Square root of 10 minus square root of 10, that cancels within itself. And square root of 4 is 2, but there's a negative out front, so that would be minus 2. So I have 5 minus 2, so that whole thing simplifies just down to 3. Remember that when we multiply by the same thing but opposite signs, we come out to a single answer, a single number, which is kind of the point of the conjugate, right? You're trying to get rid of those radicals. So that's why we multiply by the same thing with an opposite sign so that we can remain with a single number. So if you do not end up with a single number, no radical, then something went wrong when you were multiplying. Okay, so now we have this answer, but we can simplify this answer. Okay, and that is simplified because the 6, the 3, and the other 3 simplify. Now, in order to simplify an answer like this, all 3 values must divide by the same number in order to simplify. Okay. So if this was a 2 here, it was 6, 2, 3, I couldn't simplify it, okay? It has to be all 3 on the outside of the radical in order for it to simplify. Now, when I simplify it, 6 divided by 3 is 2, 3 divided by 3 is 1, but we're not going to write that, so it'd just be 2 plus square root of 10. Okay, and on the last question, or last questions, we talked about A plus BI format. When you're simplifying with radicals, it's kind of similar in that sense, but you always want to put your rational number, that's what the Q stands for, in front of your imaginary number. Okay, because remember, if it's a square root of anything but a perfect number, it would be imaginary. Okay, so that's a lot to unfold. So number 5, 2 square root of 7 divided by square root of 3 minus square root of 5. Okay. Okay, I know this is early for you to try a problem on your own, but I want you to go ahead and try that because my son is crying, so I need to go get him. Okay, let's see how that went. So we're going to multiply by square root of 3 plus the square root of 5. So that's going to give us 2 square root of 7 times the square root of 3 plus the square root of 5. Square root of 3 minus square root of 5 times square root of 3 plus square root of 5. So when we multiply, we get 2 square root of 21 plus 2 square root of 35 divided by, now we get square root of 3 times square root of 3, square root of 9 plus square root of 15 minus square root of 15 minus square root of 25. Now in the numerator, nothing actually simplifies. Oh, sorry. Nothing actually simplifies in this scenario. Okay, 21 doesn't simplify, 35 doesn't simplify. Neither of them are perfect. Neither of them can break apart. It just is what it is. Now in the denominator, we have the middle terms canceling. Square root of 9 is 3. Negative square root of 25 would be minus 5. So we're left with negative 2. And if you notice, we had 2, 2, and negative 2. Now at this point, you may have been like, well, do I divide by 2 or negative 2? In this case, it would make the most sense to divide by negative 2 so that you don't have a number in the denominator anymore. So 2 divided by negative 2 would be negative 1. So we would get negative square root of 21 and minus square root of 35. And that would be our answer. Okay, and so that one was a little bit easier. There wasn't as much simplifying, so hopefully that one didn't go too bad for you while I had to leave the recording for a bit. All right, let's try the next one. One minus the square root of 8 divided by 2 minus the square root of 8. Now in this case, we have some rational numbers and we have radicals, okay? They're not both in radicals. So when we multiply, we're going to multiply by 2 plus the square root of 8. And because we have now a binomial in the numerator, we're going to have to FOIL the numerator now as well. Oh, I just messed up there. 2 plus square root of 8. Okay. So in the numerator, 1 times 2. Sorry, my son's having his bottle right on the ground. 1 plus 2 is, 1 times 2 is 2. 1 times the square root of 8 is plus square root of 8. Negative square root of 8 times 2 would be negative 2 square root of 8. And negative square root of 8 times square root of 8 would be negative square root of 64. Okay, now in the denominator, okay? At this point, hopefully you see a pattern forming that when you multiply by the conjugate, your middle terms will always cancel. So therefore, we can kind of go ahead and start simplifying our work by acknowledging that. Now, I don't want you to simplify past that point. You do want to keep still the other terms. So 2 times 2 is 4. We know the middle terms are going to cancel, so we don't need to write it at this point. And then square root of 8 times positive square root of 8 would be negative square root of 64. So don't simplify this part too far, but we can already realize the middle part's going to cancel. All right, now let's simplify. Okay, so we have the numerator, where square root of 8 and minus 2 square root of 8 would simplify as negative square root of 8. And negative square root of 64 is actually negative 8. Okay. Then in the denominator, square root of negative 64 again is negative 8, but, is 8. So therefore we would have 4 minus 8, which would give me negative 4. Okay, now we got a lot of simplifying to do. So the 2 and the negative 8 can combine to give us negative 6. This square root of 8 can also simplify. It's the first one that could simplify in the sense of breaking it apart. Well, 8, the largest perfect square factor is 4. So 4 times 2. We got negative 4 in the denominator. This simplifies as negative 6 minus 2 square root of 2 divided by negative 4. And then all of these are divisible. So we're going to divide by negative 2, which leaves me with 3 plus the square root of 2 divided by 2. And you're going to leave it like this. I know on the last examples, we had changed it so that it was specifically A plus BI format. This method, we leave it as such. We don't break apart with the radical. Okay, so there was a lot going on in here. So we had our first binomial in the numerator. Okay, we realized that in the denominator, the middle terms cancel. Okay, there were a lot of things that simplified in here. And then specifically, we had finally had a radical that could simplify. Okay, all our other radicals haven't simplified. So that's our first simplifying. And then obviously the rule of all three has to be true. Okay, let's try our next problem. Apparently someone wants to be on camera. You gotta do your bottle book. Verse 7. Three plus the square root of 2 divided by 3 minus the square root of 2. Okay. So we're going to multiply by 3 plus the square root of 2 on top and bottom. Might try to be difficult today. And we're going to multiply. Now at this point as well, you probably don't need to keep writing that you're going to multiply. We did it for the first few examples just so you could really realize what we're doing here. Like we wrote down that we were multiplying. But at this point, hopefully you can just multiply from where it's at. If you can't, feel free to keep writing this step. But at this point, I'm just going to remember that I'm multiplying two binomials and treat it as such so that I can kind of skip that step in writing. So 3 times 3 is 9. 3 squared root of 2 plus 3 squared root of 2 plus square root of 9, or plus square root of 4. Divided by, again, when you're multiplying by a conjugate, we know the middle terms cancel. So 3 times 3 is 9. And then minus the square root of 4. Okay. So our middle terms simplify. So we get 9 plus 3 plus 3, 6 square root of 2, plus 2, divided by 9 minus 2. Tops get simplified, and we get 11 plus 6 square root of 2 divided by 7. None of those numbers simplify, so we are left with this answer. Okay, that one worked out really nicely. Yeah, this one worked out really nicely just because there, again, not a lot to simplify. So it was very similar to number 5 in that fact. Okay, now there's lots of different types of problems that can happen with the radicals. So we're going to do maybe just a couple more, and then we'll switch over to those complex binomials that I accidentally wrote down the first time. Okay, 2 divided by square root of 3 minus 1. Okay, now this example is thrown in there because it doesn't necessarily have to have the radical written second in the denominator to begin with. Now, is that proper form? Not really, so therefore we're going to not switch it. We're just going to multiply as is, okay? But it doesn't seem to look right, but we know that it'll simplify eventually. So square root of 3 plus 1. Okay, so again, don't change the order. So we have 2 square root of 3 plus 2 divided by square root of 3 times square root of 3, which again, at this point, we're starting to get more and more to the point where we can simplify faster. Okay, we know that square root of 3 times square root of 3 is going to be square root of 9, which square root of 9 is 3. And then -1 times 1 is -1. Now, if you don't feel comfortable with simplifying this fast, feel free to write down every step. So again, that would mean that it would have been square root of 9 minus 1, which would have gotten to there. Okay. But you're also welcome to simplify faster in those cases. So I'm going to simplify and rearrange. So I have 2 plus 2 squared of 3 divided by 2. All my 2's cancel. And so I have 1 plus square root of 3 as my final answer. Okay, number 9. 1 minus the square root of 2. Do you not want to drink your bottle? Divided by 2 square root of 3 minus square root of 6. Okay, so I'm going to go ahead and leave this one to you to try. 1 minus the square root of 2 divided by 2 square root of 3 minus square root of 6. So it kind of combines the two skills we've worked on. In the previous examples where we had a rational and a radical, and then also 2 radicals. Okay, so good luck on that one. Okay, let's see how you did on this one. So we're going to multiply by 2 square root of 3 plus square root of 6. Okay, we're going to FOIL the top. 2 square root of 3 plus square root of 6 minus 2 square root of 6 minus square root of 12 divided by 4 square root of 9 minus square root of 36. Then I'm going to go through and simplify. 2 square root of 3 doesn't simplify. Middle terms combine. The last term simplifies. Down here, we get 4 times 3 minus 6. So then up here, I get 2 square root of 3 minus square root of 6 minus 2 square root of 3 divided by 12 minus 6. Then it looks like 2 square root of 3 cancels with negative 2 square root of 3. So I get negative square root of 6 divided by 6. And that's my final answer. Okay, so that is the last one with our binomials with radicals. And then the last part is going to be the complex binomials that I had accidentally written earlier. And let me switch over to that one.